Okay, so we want to check here dimensional correctability. So dimensionally correct or not. So two equations from kinematics, you can definitely know these equations: s equal ut plus half at squared, and other one is s equals ut plus at squared. Now you might want to screen that one of these equation is not correct because you have already studied the first three chapters, but I'm not here to say if these equations are correct or not in and of itself, but I'm going to just say that if they're dimensionally correct or not. What does it mean when we check the equation dimensionally correct or not? So suppose you have an equation A is equal to B plus C. So A is a quantity, B is a quantity, C is a quantity. So dimensional check means on the left hand side, all the terms you have, its a dimension will be equal to the term we have on the right hand side and the term on the that is added or subtracted on the right hand side, meaning a lot of people make a mistake of thinking that the dimension of A will be equal to the dimension of B plus C. No, 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 that's wrong. The dimension of A will be equal to the dimension of B will be equal to the dimension of C. So A equals B equals C. In other words, dimension of A equals dimension of B equals dimension of C. So it's a misconception if you think that the dimension of A will be equal to dimension of B plus dimension of C, because this equation is A equals B plus C, then that's a misconception, my bro, because its dimension of A will be equal to dimension of B equals dimension of C. So let's check this equation. What is the dimension of S? Its length. Okay, all right. So meaning these two terms will have to have a dimension of length in order for this equation to be dimensionally correct. What is u? U is a velocity. Velocity is distance. Distance is length, and time is t. Distance L divided by time t. So there's a time. Okay, so ut, u is the velocity, distance by time. Here's the time. So time will cancel length. Okay, this part has a dimension of length. Checks out. What about this part? A by t squared. So a by t squared. What is a? Acceleration. Velocity by time. So velocity is speed by distance by time. So ultimately a length divided by time squared we'll have for acceleration, and a time square is already multiplied with it, so we'll get an L. Oh wow, it's true. So the dimension of S indeed is equal to the dimension of ut and the dimension of at squared. Now 1/2 is just a number, dimensionless, so it doesn't matter if the 1/2 is present there or not. So while kinematically these two equations are different, and maybe you might say that one of these equations is wrong, and I'll leave it up to you which one is wrong. But when you check them dimensionally, you're gonna have to say that both equations are dimensionally correct, because when you do the dimensional analysis, the dimension of A equals dimension of B equals dimension of C, so it dimensionally checks out.